everyone! Happy Halloween! Today we are going to be doing some notes on mixtures and solutions. So you are going to need at least one piece of paper and a writing utensil. Today's notes are a little bit longer, so you are going to probably need 2 pieces of paper if you write larger. I want to remind you guys with the notes, do not feel the need to write down every last word. Shorten, abbreviate, do what you can to make sure that you're getting down the information you need. And try not to put down stuff that you don't need. So try to shorten and abbreviate where you can. Alright, so again, we are doing Cornell notes today. So at the top of the page, we should have our title, which is Mixtures and Solutions. Below that, we're going to have our essential question, how does matter combine? Below the essential question is where we should be dividing our paper into 2 columns. As you guys already know, the larger column is where you write your notes, draw any diagrams, anything like that. And the smaller column is where you put key points, key terms, questions, things like that. At the very end of all of the notes, you will have a summary, which we'll talk about when we get to it. So, again, shorten where you can. You can see the notes on the screen, they're in complete sentences and all of that. Shorten it where you can. If you're going to sit there writing every last word, then you're going to be writing forever today, and you're not going to get done. So anyways, basic types of matter. A substance is a single kind of matter that is pure. And when we say pure, we mean that it has a specific makeup, a specific chemical makeup to it. So for example, water. And I'm going to use this example a lot in these notes. But water is a substance that has a particular chemical makeup. We also call water H2O because that's what it's made up of. It's made up of 2 hydrogen atoms and 1 oxygen atom. So water always has that makeup. It always has that chemical makeup. So that's why we refer to it as pure, because it's always, water is always that. An element is a substance that can't be broken down into any other substance. There's no way to chemically do it, there's no way to physically do it. So again, the water example. Water is made up of hydrogen and oxygen. Hydrogen and oxygen are each elements, and you can't take hydrogen and break it down into a smaller substance because it is an element. It's the smallest substance we can get at. A compound, and water is another example of this. A compound is a substance that is made up of 2 or more elements that are chemically combined in a set ratio. So what that means is the atoms are always in a particular amount. So with water, H2O. Water is always 2 hydrogen atoms to 1 oxygen atom. So it's always in that ratio. Now when the elements combine, the compounds typically have properties that are different from the individual elements that make them up. So hydrogen and oxygen separately have their own properties, but when you combine them and you bond them together in a water molecule, then it's going to have different properties because now it is water. It is now a different substance. You've taken 2 substances, 2 elements, you've brought them together, and now they combine to make something new. Now, compounds are substances. Not all substances are compounds, though. All right. Elements are also substances, but not all substances are specifically elements. Okay? All right. So mixtures. And again, don't feel the need to write down every word. Write down the important parts. Okay? Shorten and abbreviate where you can. So a mixture is made up of 2 or more substances that are together in the same place, but the atoms are not bonded to each other. So for example, if we open up a bag of M&Ms, okay? When you open it, all of the M&Ms, the different colors, are all mixed together. So that makes a mixture. Now, when you open up that bag, you're not going to see all of the M&Ms connected together, bonded together. That would be kind of weird if that happened. But they're just together in the same place, mixed up. So that's what makes a mixture. Just different substances mixed. Now, mixtures are different from compounds because each substance will keep its own properties. So, for example, if, let's imagine we've got a bag of Chex Mix, okay? And in Chex Mix, you've got all sorts of stuff. You've got the little pieces of Chex, you've got little pretzels, things like that. Now, each of those individual things keeps its own properties. You know, the pretzel is still a pretzel. The Chex is still a Chex. But they're mixed together. So each particular substance keeps its own properties. Whereas in a compound, once you combine, you bond those elements together, that compound now has properties of its own. Also in a mixture, the parts are not in some sort of set ratio. Back to water, water is always H2O. So always 2 hydrogen, 1 oxygen. In a mixture, it's not necessarily the case. You know, if you open up a bag of Chex Mix, you know, you're going to see different amounts from one bag to the next. You know, one bag might have a whole lot of pretzels, and the other might have only a few. So it's not in a set ratio. All right. Types of mixtures. There are 2 types that we're going to talk about. And that is heterogeneous and homogeneous. Now, the 2 words look similar and sound similar. So this is one thing that you might want to be careful of when you are studying these. So in a heterogeneous mixture, the different parts of the mixture can be seen, and you can easily take them and separate them. So with a bag of M&Ms, you know, we can open it up, we can pick out each of the different colors. We can pull out all of the greens and set them off to the side. We can pull out all the blues and set them off to the side. You know, with the Chex Mix example, you can pull out all the pretzels, you can pull out all the Chex, you can pull out all the other little pieces. So that makes them, those 2 examples, heterogeneous, because you can easily separate them. Now, homogeneous is when they're mixed so evenly that you can't see the different parts. And you can't just go in and pick out the different parts easily. Because you can't see the different parts. You can't see where one part stops and another part begins. So the example on the screen is Kool-Aid, and any sort of powdered drink mix in general. You know, you mix the Kool-Aid powder in with the water, and once it's mixed, you can't point out a different part of the cup and say, this is just the Kool-Aid powder and this is just the water. It's mixed so well that it's all one thing. Some mixtures are solutions. Now, a solution is a mixture that contains a solvent and at least one solute and has the same properties throughout. So an example would be the Kool-Aid. With the Kool-Aid, you know, you have these 2 things mixed together, the water and the powder, and it creates a mixture that has the same properties throughout. You know, if we look at the Kool-Aid on the screen before, it was red and it's liquid, and throughout that whole container of Kool-Aid, it's going to have those same properties throughout it. You know, you're not going to have different properties at the top than at the bottom. It's going to be the same all throughout. So anyways, a solution has 2 parts, at least 2. There's the solvent, and that is the part of the solution that is in the largest amount. This is the one that does the dissolving. It dissolves the other substances. So in the example of Kool-Aid, the water would be the solvent because that's what's dissolving the Kool-Aid powder. Another example would be if you're making hot chocolate. Some people might make it with milk, some people might make it with water. Whatever the liquid you're using is, that's going to be your solvent. Now, solutions also have at least one solute. There can be more than one solute, but there's at least one solute. There can be more, but not always. So the solute is the substance that is being dissolved. It could be gas, it could be liquid, it could be solid. So the Kool-Aid powder in the Kool-Aid example, or the chocolate mix in a hot chocolate example, those are going to be your solutes. Those are things that are getting mixed in. And those are examples of solid solutes. Sometimes you make a solution that is multiple liquids. And in that case, whatever the largest amount is the solvent, and then the ones that are in smaller amounts would be the solute. And it is also possible for a solute to be a gas. That does happen in soda or anything else that's carbonated. The reason why you have those bubbles in that carbonation is because of carbon dioxide being dissolved into it. So carbon dioxide is a solute in those particular solutions. Some more information about solutions. We've got a few different types. Dilute has a small amount of the solute. Concentrated has a lot of the solute. And when it's saturated, you've added so much solute that no more of it will dissolve. You've dissolved as much as you can, and then you added some more. So no more will dissolve. That's what saturated is. Now, solubility is a property of matter, and it is a measure of how much solute can dissolve in a solvent at a particular temperature. Solubility can change based on temperature. The higher the temperature, typically the easier it is for something to dissolve. When something is colder, it doesn't dissolve as easily. Another type of matter is a colloid. A colloid is a mixture. It contains small particles that are not dissolved and do not settle out. They're too small to be seen without a microscope, but they're big enough that if you shine a light through it, it's going to scatter the light. So there's a few examples. Clouds, fog, and there's a few other examples on the slide. And that is another type of mixture. And I believe this is the last type of mixture we're going to talk about, is suspensions. A suspension is a mixture where the particles can be seen and easily separated by filtering them out. It doesn't have the same properties throughout it, and that's because they separate out easily. So for example, if you pour water, or if you pour oil in water, they separate out. It's very easy to see what is the oil, what is the water, and it's because they don't dissolve together. It does not necessarily have the same properties throughout, and there are visible particles that are bigger than the particles in solutions or in colloids. So this would be an example of a heterogeneous mixture, because you can pick the different parts out, whereas solutions and colloids would be homogeneous, because it's the same all throughout. And that's it. I know that was a lot of writing, but you gotta do a little bit more. At the bottom of the page, go ahead and start on a summary. Should be 3 to 5 sentences long about the notes that you just took.